Okay, this is going to be a video on a decision matrix. It's also sometimes called a design matrix, and this is a tool that can be used by engineers to evaluate ideas and help pick an idea to move forward with in an engineering project. And so what I want you guys to do right now is up here, right where it says decision matrix in this little gap right here, go ahead and write down the following engineering goal. Make a paper container to hold water. Make a paper container to hold water. So write that goal right here and then start the video again when you're ready. Now, first we're going to talk about what this tool is used for, and then we're going to come back up here and I'm going to tell you what to write in here so that you can fill this out and sort of get a sense of how you might be able to use this in an engineering project. Okay, so make a paper container to hold water. Okay, what is this decision matrix used for? It is used to analyze ideas in order to rank them. And it helps a group make an objective decision which is not based on personal feelings. So go ahead and copy that into your notes and then start the video again. Okay, objective decisions can be based on feelings, they can be based on opinions. When we're working in a group, we're going to come up with several ideas to solve a problem. So you might have already thought of a couple of ways to make a paper container that can hold water, for example. And you could list those ways in this table in the different idea rows. Okay. Now, as a group of engineers working together to solve this problem, you might be attached to your own idea and somebody else might be attached to their own idea. And so if all we have to do is decide which idea to move forward with, and we don't use any kind of tool to help us with that, our personal feelings are heavily involved there, and whoever ends up losing out on the idea choice might feel hurt by that. This tool is designed to help you have an objective way to make that decision and therefore minimize people's feelings getting hurt. I mean, that's kind of a nice way to say this. Okay, so what do we put in the criteria boxes? Well, criteria, okay, characteristics that need to be in the design according to the criteria and constraints of the project. Okay, so pause the video if you need to copy that and then push play. So up here, if we are making a paper container to hold water, and I tell you it can only be made of paper, then that's going to be one of the criteria. It's made of only paper. Okay, another one of the criteria would be can hold water. And then these boxes, you can continue to add criterion. So I would say maybe easy to make might be something you'd put here. Minimizes waste. If I care about the planet and I don't want to waste paper, minimizes waste. Doesn't leak. Anything that you want to include in your requirements for your design should go in this section. Okay? As separate as you can as far as those ideas are concerned. All right. So again, if we come down here, examples, making a paper container to hold water, criteria would be holding water, made of paper, easy to make, little waste. Okay. You might say doesn't leak. Okay. One of my students today said you could put it down and it would still hold the water, so kind of stable enough to be able to put it down. It depends on what you're trying to make the paper container for, but that could be a criterion. So you're just going to come up with a bunch of different things to put in the criteria boxes for your project. Now, obviously, with a simple project like making a paper container, you are probably going to have fewer things in the criteria boxes than if you're trying to create a device that will purify water and that is cheap and easy to use in other third world parts of the world that need access to clean water. Okay, so obviously that's a much more complicated project than making a paper container that holds water. Okay. All right, possible scoring methods. So there's different ways that you can use these boxes, these white boxes in this diagram, to score out your ideas from these blue boxes using those criteria and constraints in the gray boxes. Okay, so here 1, 0, -1 is the first possible scoring method. And I'm just going to, Okay, so in this, you give each idea a 1, a 0, or a -1 for each of the criteria in the table. A 1 means it meets the criterion well, 0 is neutral, and a -1 might not meet that criterion. Now, in this system, 1s are good. It meets the criteria, so If you have ones across the board, you're going to have a high score. Whereas if you have a 0 or a -1 in there, that's going to pull your score down. So the highest score is going to win in this scoring method. So if we come back up here and take a look at this, you should have several criteria listed in these gray boxes. If you don't, please pause the video and add a few. Just at least holds water, made of paper, easy to make, at least a few. Ideas for how to make those containers, could be a paper cup. If you knew how to make a paper cup without any adhesives or anything like that, that would be an idea. A cone, that would be an idea. Those you'd list here. And then you could give each one a 1, a 0, or a -1 in each of these criterion columns, then total up the score, and the highest score would win. Simple as that. Now, this is a super simple project, so you might end up with ones across the board on all of your projects, all of your ideas, and then you wouldn't have a winner. So this might not be the rating system for you. So we scroll down, we're going to see the next rating system or scoring method is a ranking method. And this is where you rank your ideas from 1, which is the best, to your highest number, which is the worst. So if you have 3 ideas, your highest number is 3. If you have 5 ideas, your highest number is 5. So you're ranking it from 1, which is the best, to your highest number, which is the worst, for each criterion. So one of them might be the best in the ease of use or how easy it is to make, but it might be the worst in actually holding water, okay? And so you'll have a 1 for one of them and a 3 for the other one if you have 3 different ideas. But only one idea can get a 1, only one idea gets a 2, etc., until you've used all of your rankings. So no 2 ideas can share a ranking. And again, this is probably going to be better for a more complicated engineering project versus making a paper cup that holds water or a paper container that holds water. But you add the scores, and in this case, the lowest score will win because, again, 1 being the best, if you have 1s across the board, that's going to be a very low score. All right, our final idea for scoring is going to be a rating scale. This is where you create a scale. For example, 1 to 10, higher is better, and you're going to rate each criterion for each idea. It is possible for 2 ideas to be equally easy to make, so they might score the same in that scale for the criterion. Okay, so if I asked you to rate different flavors of ice cream on a scale of 1 to 10, you might have more than one flavor that absolutely disgust you and you'd give both of them a 1. In this case, that's okay. We're not ranking them, we're rating them, and it's okay to give 2 things the same rating, not the same ranking. Okay, hopefully that's clear. But if this is our scale, higher is better, then our highest score is going to win. And so this might be the most appropriate scale for a project as simple as making a paper container, because then that gives you a little bit more flexibility for rating, how easy is this to make? Is it a 10, super easy, or is it an 8, which is still pretty easy to make? So those are going to be things, this is a scale that you can use for a more simple engineering project like making a paper container to hold water. So after you have all of those notes done, that's the end of the notes, and you can move on to the pre-lab on the next assignment.